So now we'll get started with a subject called as computer organization and architecture. Very, very important subject for any software engineer, for anyone who is working on either hardware or software or any part of the computer science ecosystem itself, right? So in computer organization and architecture, we learn how a computer works internally, right? We learn how a computer works internally, right? This is very, very important. And of course, we will build upon the basics that we learned from digital logic design, right? So we have studied digital logic circuits and design, right? So we have studied this subject called digital logic circuits and design. Now, you need to understand the basic concepts from digital logic circuits and design to be able to understand how computers themselves work. So think of this as a prerequisite, right? Think of this as a prerequisite for this, right? I'm assuming that you know the basics of digital logic circuits. When I say a decoder, you understand what a decoder is. Again, I'll assume that these basics are known to you, right? And I'll build on top of the concept that you learned in digital logic circuits to understand how a computer itself works internally, right? How a computer is organized, what is memory. Again, by the end of this whole course in computer organization and architecture, you'll be able to explain everything about the internals of a CPU. You'll understand how a CPU works internally, how your RAM works, right? How input-output to any device works. Again, you may have heard of these terms, right? If you have ever opened your computer, you'll see a central processing unit. You'll see processors like Intel's i3 processors, i5 processors, all of these things. Again, you may have encountered RAM. Your laptop may have 4 GB of RAM or 8 GB of RAM or 60 GB of RAM and things like that. Of course, your system also has multiple I/O devices. Be it be your keyboard, be it be your mouse, be it be your hard disk, right? All these are input-output devices. By the end of this whole course in computer organization, you will be able to explain how everything is connected and how everything works, right? So that's one of the most important things. Then your obvious question should be, why should I learn all of this? Because at the end of the day, any program that you write as a software engineer actually runs on a computer. Of course, there are different types of computers. Look at this. Your smartphone itself is a type of computer. Your smartphone is a computer. Your laptop is a computer. Even your smartwatch is a computer. So anything where there is a processor inside is a computer of some sort or other, right? So similarly, if you ever want to work in IoT, right? If you ever want to work in this very fast growing field called IoT, you need to understand, because in IoT, we have these systems called as microcontrollers. So IoT uses a bunch of microcontrollers. Again, microcontrollers are special type of, so a microcontroller basically consists of a microprocessor or a CPU along with RAM, along with some IO devices, all of them packaged into one single chip. I'll give you an overview of a few core IoT devices also. So IoT being one of the core areas that is growing very fast. If you want to work in areas like IoT, you need to understand computer organization and architecture very, very well. Similarly, if you want to understand things like, if you want to understand how an operating system works, again, we have a course in operating system also. This is a mandatory course in most undergraduate computer science curriculum. If you want to understand how an operating system works, it's very important you understand how a computer is organized and the whole architecture of the computer itself, because at the end of the day, an operating system is built on the physical hardware, right? So if you look at this, again, in computer organization and architecture, you will understand the whole hardware. You will understand the nitty-gritty details of all of the hardware required. So if you ever want to become a hardware developer, right, understanding computer organization along with digital logic circuits is extremely important if you want to have a career in it. Even software engineers, it's not limited just to hardware engineers, or if you want to become a developer of operating systems or IoT systems, it's not just limited to this. If you want to write good software, if you want to write good optimal software, again, I have used in my own professional experience to write very, very complicated software or very, very highly efficient software. I had to use concepts that I learned in computer organization and architecture as part of my undergraduate studies. right? So if you want to write extremely efficient software, even software engineers need to understand concepts like registers, right? They need to understand concepts like cache memory. They need to understand concepts like how the CPU fetches data from RAM. What are interrupts, right? So all these concepts that we learn as part of computer organizational architecture are extremely important for you to become even a good software engineer in the real world. And if you want to understand subjects like operating systems, even compiler design, because what does a compiler do? The compiler takes the software, takes any program that we write and converts that into machine level language. This machine level language has to be executed on a computer, on an actual computer, right? So if you want to understand the subjects of compiler design, even databases, even to some extent, if you want to understand the subject of databases, because databases worry a lot about how to optimize your disk space, how to optimally use your RAM, how to optimally use your CPU and all of these things, right? So computer organizational architecture is a very foundational subject, which is mandatory if you ever want to become an IoT engineer or a hardware engineer. Even if you want to become a software engineer, this is something that will save you when you have to write highly efficient code, and it gives you a better understanding of other core components of a computing system, like a how does a Windows operating system work? How does it connect to the hardware? To understand how the Windows operating system works and connects to the hardware, first we have to have an understanding of how the hardware or the hardware components of a computer are organized and how the whole architecture works, right? So this is something, again, whether you want to, again, in your life, if you want to design hardware products like a smartwatch, if you ever want to build a smartwatch or any IoT system for that matter, having a good understanding of computer organization is mandatory, right? You cannot escape that fact. So all those amongst you who want to become good software engineers and very importantly, good IoT engineers, again, this is a very, very fast growing field with lots of requirement today as more and more things are sensorized. As we have done, like building a smartwatch is also an IoT device, right? So building a smartwatch, again, I have not worked in hardware design professionally, but I always tinkered with IoT devices. I played around with special purpose IoT chips. Again, this is my hobby and I've thoroughly enjoyed it. During my BTech days, computer organization, architecture, microprocessors, all these were some of my favorite subjects because I could physically see what's happening. Again, some of you may have this subject called microprocessors. Some of you in some universities, in addition to computer organizational architecture, you may have a subject called microprocessors where you actually learn about real microprocessors, how they work internally, etc. Again, electronics engineers learn much more about microprocessors, but even computer science engineers and IT engineers learn about microprocessors in addition to computer organization and architecture. So if you want to understand the internals of microprocessors or microcontrollers, CO or computer organization is super duper important to get a grasp of, right? So now let's understand. Let's get started very, very slowly with some simple concepts, right? What is a computer? At its very basic level, a computer is basically an electronics device which takes some input data, which takes some simple input data. It also takes a program, right? This program, again, this is called the concept of a stored computer or a programmable computer. Imagine if there is no program, this could just be a simple electronic circuit. Look at this. If you just take a system where you can't write programs, right? Where it takes some input data, there is a simple electronic circuitry here, it generates an output. Like the circuits that you may have studied in digital logic circuits, right? Look at this. There are some digital logic circuits wherein you give some input, it generates some output. But you can't change how the input is transformed into output using a user given program. So the computers that we will study are called programmable computers, right? So the computers that we will focus on are called as programmable computers. This is very, very important. Okay. And this high level architecture is called as John von Neumann architecture, right? So this is often referred to as John von Neumann architecture of a computer. Now, this is also referred to as the stored program computer, or it's also called as the stored program architecture. Again, for those of you who don't know, John von Neumann is one of the great mathematicians who came up with what is a computer. He said computers are not just some simple electronic circuitry where if I give input, I can generate output. He said, no, there needs to be a program, and this program, we can change the program the way we want. Based on how we write the program, the input is transformed to the output. So this is called as the stored program So this is called as the stored program architecture or stored program configuration or a stored program computer, right? Because I could just take a simple electronic circuit with logical AND OR gates, give it input, it will give you output, right? You just give it input, it will give you output, right? That's very simple. But what we want our computer to do is the computer should take the user given programs, and based on what this program is, it should go from an input to an output. That's very, very important, right? So now what is a program? So again, we'll understand programs, we'll understand instructions in much more detail. A program is basically a sequence of instructions. Remember, at the end of the day, everything that we give to a computer is binary, because a computer is a digital circuit which only understands zeros and ones, right? Now, how do you give an instruction? A program is literally a sequence of instructions. If you look at a C program, it's basically a sequence of instructions, right? You say, okay, allocate this variable, then change this variable to this, so on and so forth. So the C program you write, a compiler takes that, the C program, converts it into a machine level language. A machine level language is basically binary language, where you have a set of instructions like this, right? So this is also called as an executable code. You may have heard of some of these terms, right? A program is basically a set of instructions. Now, what is an instruction? At the end of the day, remember that a computer is a binary device. It's a digital device which can only understand binary. So an instruction is basically a binary sequence. So for example, so it's basically a binary string or a binary sequence, right? See, look at this, your program here is a bunch of instructions, right? Your computer first will read this first instruction. Of course, this instruction is basically a binary number, 10110 something. But each computer, based on the way the computer is designed, or based on the way the processor, again, here when I say computer, we are talking mostly about the processor or the central processing unit, right? The most important component of a computer. CPU is what makes a computer, right? So your instruction is a binary sequence or a binary string. You can also think of it as a binary string. And your computer literally takes each of these binary strings, interprets them, and based on what the string is, it will transform your input to output data, right? So all of your data, your input, output data, they themselves are binary strings. They themselves are binary sequences or strings. Remember, everything in a computer is binary. Okay, everything is binary. Okay, while we may use decimal numbers to understand it and to interpret it, at the end of the day, a computer only understands zeros and ones, because at the end of the day, it's a digital circuit. It's built using digital components like your logical OR and all these types of gates that you studied in digital logic circuits, right? So that's very, very important. So we will focus in this course only on programmable Neumann architecture or stored program based computers. The program is a very important component here. If there is no program, imagine if I just have input data and some electronic circuitry, I have output data. That's not a computer. Okay, as far as this course is concerned. Okay, we'll focus only on programmable computers here, right? So now if you look at the block diagram of what a computer is, again, this is a very, very high level diagram. This is just a block diagram. We will go into the depths of it. We'll understand how the CPU works, how the memory works. Again, look at this. You have your CPU, or it's also called as the processor or the central processing unit. Whenever you say that my laptop has an i3 processor or an i5 processor or an i7 processor or an AMD processor, what you're talking about is the CPU itself. This is what you're talking about, right? Your CPU has a bunch of input-output devices. Okay, so your keyboard is an input device. Your mouse is an input device, because whatever the mouse does, the CPU takes that as input and acts upon it. Your touch screens, again, your computers come in all shapes and sizes, as I told you, right? Your laptop, your smartphone, your smartwatch, all of them are actually computers. So if you have your smartphone as your computer, the touch screen is a very important thing. Or you may have a touch screen laptop. Your scanner, your printer is an output device. Your scanner is an input device. Your monitor on which, or your screen on which you're seeing this video, is an output device. Your disk on which you store your data permanently, right? So your disk, like your hard disk drive or your solid state drive or your pen drive, right? Or your pen drives or thumb drives, as they're sometimes referred to as, or your SD cards, right? All of them are referred to broadly as disk, right? Even your Wi-Fi card, look at this. If you're watching this on a laptop or on a smartphone, you have a Wi-Fi card, which is actually a piece of electronic circuitry that communicates with your Wi-Fi router. That's also an input-output device. So all these are called as I/O devices, where I/O stands for input-output. So a computer has a processing unit. This does processing. Then you have memory and you have I/O devices. The memory itself broadly can be categorized into main and secondary memory. Your secondary memory is nothing but your disk memory where you store data permanently. Your main memory is what we'll focus on. One of the very popular main memories is your RAM. There is also read-only memories. Okay, there are RAMs and ROMs that are there. If you ever open so look at this. If you open your motherboard, this is a typical motherboard that you will encounter on your computer, right? So this is your typical motherboard. If you look at the motherboard has lots of chips here. Again, I'll go ahead and give you an overview of what's happening here. But your RAM, your main memory, RAM is the most widely used form of main memory, right? We all know about RAM, right? You say my computer has 4 GB RAM or my smartphone has 2 GB RAM, right? So RAM is basically where the CPU stores all the programs, stores all the data, but as soon as the power supply is gone, everything in the RAM gets washed out. Or in other words, you lose all the data that is there in the main memory. So this is also called as volatile memory. Why is it called volatile memory? Because as soon as you turn off the power, suppose you switch off your smartphone or you turn off your laptop, everything that's in the main memory. Here when I say memory, we're talking mostly about main memory. There is also secondary memory. The secondary memory we're talking about is the disk. Whether it's your pen drives, your SD cards, your hard disk drives, your solid state drives, all of them are your disks. So all of them, your secondary storage is where you store data permanently. But the CPU talks to main memory. Main memory mostly consists of RAMs and ROMs. Again, ROM basically means you write a program or you write something and you can only read from it, you can't write to it. RAM basically means random access memory. You can read and write your main memory. Look at this. You can write data to it or you can read data from it to the CPU. Again, there are a lot more details. I'm just giving you a high level block diagram. The memory that I'm talking to here is called the volatile memory, mostly consists of RAM and ROM. Okay. Again, ROM, you can only read from a ROM, you can't write to a ROM, right? The most popular type of main memory that we all use, that we all know about is called the RAM. Okay. So now if you ever open your, look at this, if you ever open your laptop or desktop, you see something like this. This is called as a motherboard. This is called as the motherboard. Okay, a motherboard is a piece of, it's basically a big chip, or it's basically a big PCB. It's called as PCB, printed circuit board. This is called as a printed circuit board. Okay, this is a huge piece of circuit board on which multiple components lie. Look at this. Here is called the CPU socket. Whether you buy an i3 processor, i5 processor, whatever it is, you place your CPU here. This is your central processing unit. These are called as RAM slots. Look at this. These slots that you see here, these are called as RAM slots. And you may have encountered something like this, right? This is your RAM chip actually. This is your big RAM chip. You take this and you plug it into this, right? So those are called as RAM chips, right? Again, if you have a sound card or anything that you want to connect to, right? So these are called as PCI slots. The PCI slots help you connect to other I/O devices. Then you have a graphics slot here where you can put a graphics processing engine or a graphics processing or a GPU as it's called. If you have a lot of graphics intensive work, like if you're doing work on Adobe Photoshop or anything graphic, or if you're doing some animations, you might want a special chip that can do this graphics work faster, right? Then you have this back panel here where you have connections to USB, your monitor, all of the connections are here, right? Again, look at this. You have these connectors here to which you can connect your hard disk drives. So literally what's happening here is this is your whole motherboard. Your motherboard works as the electronic circuitry or the printed circuit board which connects various components. Of course, on your motherboard also there are some ROMs which store some default programs. As soon as you turn on your computer, there is actually a piece of software that is stored in a ROM that starts executing because this is read-only memory, right? So effectively what happens is, again, this is a high level view. I'm just trying to connect these components, this block diagram to the physical thing here. If you ever open your laptop or desktop, you'll see a printed circuit board or a circuit board like this. Okay, if you've ever seen this, these are your RAM chips, right? I hope you got a good, again, I'm trying to connect the physical stuff that you will encounter to the block diagrams, right? So similarly, I was talking to you earlier about IoT, right? So there is this very popular chip called ESP32 chip. Again, these are stuff that I've worked with, that I've played around with, not in my professional career, but it's as a hobby. Okay, this is called as an Arduino chip. This is called as an Arduino chip. Okay, or this is called as an Arduino board to be precise. This is your Raspberry board. This is your Raspberry Pi board. So this is a very small chip. This is literally one chip. See, look at this. This whole thing is your ESP32 chip. Okay, if you ever want to build an IoT application, for example, imagine you want to build an application where you want to have a small chip that you place on your garden or in a farm. Let's assume this is my farm. Okay, let's assume this is my farm. Okay, this is my ground level. So I might want to build a system where I have a small electronics chip here. I have a small electronics chip. I have a sensor that measures how much humidity or how much water is in the ground, so that any plant, any plant or anything that I want to grow grows well. Look at this. If there is more humidity or if there is more water content in the soil, the plants can grow well. So I can design an IoT circuit here, which basically has a small sensor which goes into the ground, right? I can design it using this simple IoT sensors. This is a very small chip. Look at how small it is compared to a human finger. This chip, this single chip consists of a CPU. It consists of RAM. It consists of IO devices like Wi-Fi and Bluetooth communication devices. This small chip, literally this small chip has everything inside this. So such devices are called as microcontrollers. See, your CPU is called a microprocessor. This is called as a microprocessor. Okay, so microprocessor only does the processing work of taking inputs and generating outputs with help from memory and IO devices, right? So a microcontroller on the other hand. So these are called as microcontrollers. A microcontroller is a full-fledged computer which has the CPU, RAM, IO devices, all the electronic circuitry. This is a very, very popular IoT chip which is gaining lots of popularity in the recent past. But there are also other hobbyist tools like Arduino boards. This is very, very popular. So an Arduino board also has a RAM, CPU, a bunch of IO connections. So I can connect devices to this. So all these dots here, all these holes here, I can connect input-output devices to these. Okay, I can power it up using USB by I can power it up using a simple connector by powering it to a 5-volt power supply. Okay, this is my USB connector to write programs onto this chip. Similarly, Raspberry Pi is another very, very popular hardware or a microcontroller based architecture. Again, this is also this is palm size. Roughly an Arduino chip is the size of your palm. A Raspberry Pi chip or a Raspberry Pi board, these are not called as chips, these are called as boards. Okay, this is also an Arduino board. While the ESP32 is a chip, it's literally one chip. It's literally one chip that has everything. So if you ever want to build IoT applications, remember that microcontrollers are your way to go. But to understand microcontrollers, a microcontroller is nothing but it's basically one chip on which all of these things are packed together. So we will study, as far as most computers are concerned, we'll study CPU separately, memory separately, IO devices separately. But what is a microcontroller? Everything put together. Everything put together in one beautiful chip, one compact chip like this, right? So if you ever want to become an IoT engineer, you need to focus on this course. Just wanted to give you that motivation before we dive into the nitty-gritty details of understanding how a computer itself works.